Welcome to Tatomasi. So this is a question asked in JEE Main 2016. So we are going to discuss a question which is asked in 2016 JEE Main. So first of all, I will read the question, and I will read it multiple times so that you will understand the question, and we will directly get into the solution and we will say it. Okay. So the question is, I will read it. See. Let me see the question. Yeah. Okay. This is the question. So the question is from we are discussing the all the videos we are here we are discussing is about electrostatics, right? So most of the portions electrostatics we cover, and we have discussed many questions previously asked JEE mains, JEE advanced, many questions we discussed, right? So this is a question that is asked in 2016. Let me read the question. The region between two concentric spheres of radii A and B, two concentric spheres, radii A and small b, respectively. It's shown in the figure, you can see it. It's shown in the figure. Has volume charge density. Volume charge density is denoted by the letter rho is equal to capital A by small r. Rho is equal to capital A by small r. One important thing, where A is a constant, they are defining A as a constant and r is the distance from the center. R is the distance from the center. So once again I will tell you, the first sentence I will read it once again. The region between two concentric spheres of radii A and B. There are two concentric spheres of radii A and B respectively, has volume charge density rho, where A is a constant, R is the distance from the center. So this volume charge density, one important point here is this volume charge density is defined for the region between two concentric spheres. So what is the region between these two concentric spheres? The region between these two concentric spheres is, this is the region, and you can see this is the region between the two concentric spheres. So this region is having the volume charge density rho is equal to capital A by small r. This small r is a variable. If you are taking the area here, the distance should be this. This small dA, if you are considering, this should be, that is a variable, where capital A is a constant. So you understood the first point in this question. The question is, once again I will read it. The region between two concentric spheres of radii A and B. Region is this one, the shaded portion between the concentric spheres. That region has a volume charge density rho is equal to capital A by small r. Capital A by small r, where A is a constant, r is the distance from the center towards that region. If you consider a small area dA, then r is a variable, small r is a variable. Then at the center of the sphere is a point charge q. At the center of the sphere there is a point charge q. It's simple. So to understand that sentence, it's very simple. The value of A such that the electric field in the region between the sphere will be a constant. What they are asking is, what is the value of this capital E in the volume charge density? They have given capital A. right? Not this small a. That is a constant. So we have to find out rho. This capital A is also a constant, but what is that value in terms of A and B? What is the value of capital A, so that the electric field between these two spheres is a constant? This is the question. You understood the question? Once again, I will read it. The region between two concentric spheres of radii A and B respectively has volume charge density rho is equal to capital A by small r. This A only we have to calculate. That capital A we have to calculate. That A is a constant, r is the distance from the center, that small r is a variable. As the center of the sphere is a at the center of the sphere is a point charge q. Here it is a charge q. Then they are asking what is the value of A, capital A, such that the electric field in the region between two spheres will be a constant. So this is the question. So you understood the question. So we can directly get into the solution. So let me read the options given. So what is the value of electric field? So once again the question is, there are two concentric spheres, small a and small b are the radii. The inner sphere, the radius is small a. The outer sphere, the radius is small b. So in this, the region between these two spheres is having a volume charge density rho is equal to A by R. So this is the region between these two spheres. That region is having a volume charge density rho is equal to capital A by small r. Then they are asking what should be the value of A, what should be A for the electric field in this region. For the electric field to be constant between these two concentric spheres, the electric field must be constant. For that, if it is constant, what is the value of capital A? This is the question. And capital Q is the charge at the center. They kept a charge Q at the center. Apart from that, this area is having a volume charge density capital A by small r. So the options given here are Q by 2 pi A square. A is the inner radius. Q by 2 pi B square minus A square. 2Q by pi into A square minus B square. 2Q by pi A square. Understood? So what are the answers? Q by 2 pi A square. Q by 2 pi into B square minus A square. 2q by pi into A square minus B square, then 2q by pi A square. What should be the answer? So if you get this type of a question, so how do you approach it? That's what you have to think. So anyway, electric field, you need to find out the electric field and finally prove that it should be a constant, and that for that to be a constant, we have to get the value of capital A. That's the question. So to get the value of electric field, here you have to go back to Gauss's theorem, right? Because here we can't, get the electric field by using the fundamental formula F by Q. That we cannot use it. Here we cannot, predict the amount of charge distributed in this area, because charge Q is sitting here and this area is having a volume charge density as well. So we have to calculate the total amount of charge. So that formula we cannot use it. Then another formula you are having is 1 by 4 pi epsilon 0 into q by r square. That also you can use it when there is a finite charge and one sphere or one spherical conductor or it is there, you can use it. But here two concentric spheres. So we have to use the Gauss's theorem. So Gauss's theorem states that the total electric flux over a closed surface is 1 by epsilon 0 times the net charge enclosed by the surface. That is phi is equal to 1 by epsilon 0 q. Right? In integral form, or we can write it as surface integral of E dot dA is equal to 1 by epsilon 0 times q. So we are starting from here. E dot ds. dA we have taken as ds is 1 by epsilon 0 q. So here the variable, this small a is a constant, small b is a constant, capital A is a constant, small r is a variable. For example, in that area you are considering this area, you can take any small area dA. If you are taking a dA here, this should be the distance small r. If you are taking a dA here, this should be the distance. So in this r is a variable. It can have any value based on the small area you are considering it here. So E into ds, I am assuming this is the dA and this is the r. So E into, we can take it as ds should be the surface area. So it should be E dot dA is equal to 1 by epsilon 0 times q. So E into 4 pi small r square. I am taking a small area dA and the distance, that is a variable, but here we are assuming r is the distance towards that dA. So E into 4 pi r square is equal to 1 by epsilon 0 times q. What is q here? So q has two components. I can tell q is the sum of two aspects. One is the charge located at the center, because of charge is there, capital Q. When you are considering this area, capital Q, plus due to this area is having a volume charge density. So because of that, we have to consider the amount of charge. So the sum of those two things, capital Q is the charge at the center, and if this area is having a volume charge density, they have given it as rho is equal to capital A by small r. So Q should be the sum of the charge from here and from this charge density. So Q is 1 by epsilon 0 times capital Q plus, how we will get the charge from this volume charge density. So this is a small area dA, its volume should be, we can take it as dV. So it would be, rho dV. So volume charge density is, the formula for volume charge density. Volume charge density rho is equal to charge by volume. So volume charge density is equal to charge by volume. So charge, how we will get the charge from volume charge density? Rho into volume. You will get the charge from volume charge density when you multiply with volume. You have linear charge density, charge by length, surface charge density, charge by area, volume charge density, charge by volume. Okay? So you have rho into dV. So we are taking dV, then we are integrating. Integrating from the limit a, this lower limit, to r, a to r. Understood? So this step you understood? So a to r rho dV. Then 1 by epsilon 0 q plus rho. I am substituting. What is rho? Rho we have capital A by small r. I have substituted as rho is capital A by small r. Rho here I have substituted as capital A by small r, that is given in the question. Rho is capital A by small r dV. So what should be the small area? So the volume dV. dV we can take it as the surface area into the small thickness dr. So dV should be 4 pi r square into dr. That is the volume. So volume should be the total surface area into thickness of radius r. So dV we have to consider it as 4 pi r square into you can take it as dr. That is the value of volume. The total surface area you have to consider that for the this area that should be like a Gaussian surface enclosing that, considering the total area. So 4 pi r square, the total surface area into small thickness, that will give the volume dV of that So you have to consider a concentric sphere. So our consideration is this. This is based on this only we are defining. So that sphere, this is a variable. That sphere, its limit is from A to B. So that sphere, that R is a variable. So its volume, this concentric sphere, its volume is 4 pi r square into dr. Okay. So now again 1 by epsilon 0 q I am taking, integrating here. So when you here. So 1 by epsilon 0 into q, again 4 pi a constants I have taken. This r and this r square is cancelled. This r and this r square you can cancel. The remaining thing is integral of r dr. Integral of r dr is r square by 2. The limit is a to r. A to r. So when you apply the limit, you will get it 1 by epsilon 0, everything same, q, upper limit 2 pi a, r square minus a square, upper limit into lower limit. So here this 2 and this 2 and this 4 will be cancelled. You will get 2 and 2 pi a r square minus a square. Simple integration. It's very easy. You can easily understand. So now I am trying to, here E into 4 pi r square only this quantity. So now I am finding out the value of capital E. So you won't be able to see whatever I have written. I will just adjust it. 1 second. So now you can see that. So now I have written in another board. You can see a small board there. There I have written the value of E there. So you can see it. So what is the value of E there? E is equal to, I have, what are the only thing I have done is, you have E into 4 pi r square only, that quantity. I bought that 4 pi r square this side. So it would be epsilon 0, 1 by epsilon 0 is already there. So it is 4 pi r square epsilon 0 into q plus 2 pi a into r square minus a square. So this is the thing when I will get 4 pi r square when I bring it in the right hand side. When you multiply it, q pi 4 pi epsilon 0 r square, this term again I am multiplying with, there are two terms. It is this term when you multiply 2 pi a r square by 4 pi r square epsilon 0. That is a by 2 epsilon 0. When you multiply this and 2 pi a r square, I am doing it in a single step. So you will get a by 2 epsilon 0. The next term will be minus, you are multiplying this with 2 pi capital A small a square. You will get capital A small a square into 2 epsilon 0 r square when you multiply it. So if you analyze these three terms, the one and only term it is constant is a by 2 epsilon 0. That is a constant because they have already given capital A constant. We know epsilon 0 is a constant. It is the permittivity of free space and its value is 8.85 10 raised to minus into 10 raised to minus 12 coulomb square, Newton raised to minus 1, meter raised to minus 2. It's a constant, you know. So its units and dimension are very important. Most of the time you will get the dimension through JEE and NEET exams. So this is already a constant. So these two are the variables to be, to get E as constant. This is a plus term and this is a minus term. So to be if E has to be constant to become, you have to get E as constant, then these two should be equal. That's what I am trying to say. Then only E is a constant because these two contains the variable term R. So for E to be constant, this plus term and minus term should be equal. So we are equating it. Q by 4 pi epsilon 0 R square is equal to A into E square, capital A into small a square by 2 epsilon 0 R square. Why we equated it? Because these two terms are variable. For E to be capital A, intensity of electric field to be constant, these two should be equal and they must be, then they will cancel each other and then these two terms become 0. They have to cancel each other. Then this entire term is a constant, then E is a constant. So you have written q by 4 pi epsilon 0 r square is equal to a square 2 epsilon 0 r square. From here you will get it as capital A is equal to q by, you cancel, epsilon 0, then 2 and 4 you can cancel, here you will get 2, this r square and r square you can cancel, then you will get capital A as 2, but here you will get 2, right? 2 pi a square. So this is the answer. So this is the first choice, right? 2 pi a square. So this is the question. So you understood this. So why you equated these two terms? For capital E to be constant, these two variables are plus and minus, so they must be equal and then they cancel each other. So that's why we equated it. So this is a question asked in 2016 JEE main. So that's what we just solved it. So if you have any queries, or you can ask below the video, you can ask me. So this is a very good question. When you practice these type of questions, you can solve any type of problems. So what are the questions? We have discussed many questions from electrostatics. Those are all previously asked IIT JEE questions. So you can solve these questions. Once you solve these questions, you will get the capacity to do any tough problem. Actually, these exams are very easy. You need some hard work and dedication. Please do your work. Everything should be easy. Thanks for watching. So thanks a lot.